Find the derivative of y equals the square root of 8x squared plus 6x plus 5 quantity to the third power. Then evaluate y prime of 2. Y here is a square root of an entire expression, 8x squared plus 6x plus 5 raised to the 3 power. The first thing we need to do, because of the root, is to rewrite this with a fractional exponent. It is the expression 8x squared plus 6x plus 5 raised to the power of 3 and then second or square root, so 3/2 power. The derivative will therefore involve the power rule, since the power is the outermost function, but because what's raised to the power is an expression, we will also have to make use of the chain rule. The derivative y prime, which can also be called dy dx, is going to equal the power rule. We will bring the power down, leave the entire inside alone, and then subtract 1 from the power. We will call that 2/2. But because what's raised to the power is not just an x, but an entire expression, the derivative won't just be a 1, it'll be something bigger. We have to take the derivative of the inside. The derivative of the inside, 8x squared, will be 8 times 2, 16x to the first power. The derivative of 6x will be the constant 6. The derivative of 5 will be a 0. That's the chain rule. The 16x plus 6 can be written out front with the 3/2. And we will have the 8x squared plus 6x plus 5 to the 3 minus 2, which is 1 over the 2, 1/2 power. So y prime, or dy dx, will equal to 3/2 times, now the 16x plus 6, it has a common divisor of 2. I want to bring that out because I have a 2 in the denominator from the 3/2, and we'll be able to cancel those 2's out. So let's bring a 2 out to leave us with 8x plus 3. And then that 2 and that 2, one in the numerator, one in the denominator, can now cancel. You have to factor it first so that it's multiplying to be able to do that. And then we have 8x squared plus 6x plus 5, all raised to the 1/2 power. So we have 3 times 8x plus 3. And then 1/2 power means first power and square root. So square root of that entire expression, 8x squared plus 6x plus 5. So there's our derivative, y prime, or dy dx. The next thing to do is evaluate y prime of 2. Y prime of 2 means to plug a 2 in for each of the x's. So we'll have 3 times 8 times 2 plus 3, and then times the square root of 8 times 2 squared plus 6 times 2 plus 5. We will have 3 times 8 times 2 is 16, plus 3 is a 19. And then we have the square root of 8 times 2 squared, which is a 4, plus 6 times a 2, which is a 12, plus a 5. 3 times 19 outside of the root, that's a 57. And then we have the square root of 8 times 4, which is 32, plus a 12 plus a 5, which is plus a 17. So this is going to come out to 57 times the square root of 49. And the square root of 49, being a perfect square, will be a 7. And so we have 57 times 7, which will be 399.